Dawn breaks again as a significant event is about to unfold at the Lianyungang petrochemical industrial base in Jiangsu province, China. The erection of an expensive and colossal vacuum distillation tower is about to take place. The vacuum distillation tower is a core component of petrochemical plants. This one stands 58 meters tall with a diameter of 7 meters. With all its attachments, it weighs 1,600 tons, the equivalent of 6 Airbus A380 aircraft. It is to be hoisted to its fixed installation position as high as a 10-story building. Any minor misstep could cause irreversible damage and serious injuries to the personnel involved. So, what equipment can take on this challenging lift? With a maximum lifting height of 216 meters and a maximum lifting capacity of 3,600 tons, this is the beast that can lift 60 high-speed rail carriages to the height of a 72-story building in one go. It is the world's most powerful crawler crane, a 4,000-ton monster. On Jiangxing Island in Shanghai, 420 kilometers south of Lianyungang, a giant ship is about to be tested to the limit. It will lift a barge weighing 13,200 tons, a weight equivalent to the combined weight of the Eiffel Tower and 12 Airbus A380s, 1.1 times its rated maximum lifting capacity. It is a grueling overload. Itself weighing over 80,000 tons, the ship is 300 meters long and 58 meters wide. Its deck area is equivalent to 2.5 football fields. Capable of navigating any area in the world, when fully fueled, it could circle the Earth 1.5 times. It was used to install the vat-immersed tubes for the Hong Kong-Zhuhai-Macau Bridge, the largest sea-crossing bridge in the world today. It is Zhenhua 30, known as Hercules on the Sea. It is the crane vessel with the world's largest single-arm lifting capacity. Further to the south, 860 kilometers away from Changxin Island, lies Jiangzhou, Fujian province, often referred to as the Garden City of the southeastern coast of China. Here, the construction of the Fuzhou-Xiamen-Jiangzhou high-speed railway is in full swing. The Fuzhou-Xiamen-Jiangzhou high-speed railway is Fujian's second high-speed railway. Upon completion, it will operate at a speed of 350 kilometers per hour. However, the 300 kilometers of railway that connects Fuzhou and Jiangzhou must traverse 85 bridges and 33 tunnels, up to 84.3% of the track. Furthermore, the whole thing is supposed to be completed, up and running, in just 5 years. What sort of equipment can complete this complex project on schedule? 91 meters long, 20 meters wide, and weighing 680 tons. This mega tool features a trough-shaped body, 224 wheels, and a laser radar system for autonomous driving. It can effortlessly lift 1,000-ton precast concrete box girders and build a 1-kilometer high-speed railway bridge in just 12 days. It is China's first 1,000-ton level bridge girder erection machine. The rapid development of China's economy has spurred successive upgrades of domestic lifting equipment, from the initial 100-ton level to 1,000-ton level, and to today's 4,000-ton level. Large-scale lifting equipment is pushing China's industrial manufacturing to new heights. This has made it possible to lift supersized and super heavy equipment like the vacuum distillation tower in one piece. At the Lianyungang petrochemical industrial base, the sling of the 4,000-ton level crawler crane has been attached to the vacuum distillation tower. Everything is ready. The crawler crane weighs nearly 6,000 tons with a boom that is 216 meters long. Each of its tracks weighs 180 tons and is composed of 105 individual track pieces, each weighing 1.7 tons, equivalent to the weight of a family car. It is undoubtedly a giant. At this moment, one end of the vacuum distillation tower is gradually being lifted. The 60 steel cables, each 4 centimeters in diameter and bearing a load of 35.5 tons, are stretched taut. The tower's steady erection begins. The massive crawler crane didn't come out of nowhere, being preceded by 1,000-ton and 2,000-ton level cranes. To a layperson, the 4,000-ton level crane is just a proportionally larger version of its predecessors. While compared to the 1,000-ton level crane, the 4,000-ton level crawler crane has increased its vertical lifting capacity from 1,000 tons to 4,000 tons, but in fact this means a 6-fold increase in lifting torque. Similarly, its weight is just over twice that of the 1,000-ton level crane. So, what enables it to maintain such a slim figure while increasing its lifting torque 6-fold?
设计理念跟我们原来做的1000吨、2000吨完全不一样了。它自身就有3000吨的重量，加上前面雕的3000吨，后面还要有相应的3000吨的配重，这么压着，加起来有10000吨。那10000吨如何实现这个行走啊、转弯啊等等，都是特别大的难题。俗话讲，99归一嘛。我们觉得产品大到一定程度，我们需要化大为小，化繁为简。 所以我们就采用了一种模块化、平台化的设计理念。
The design team set 3 basic criteria. The crane must be able to lift, to move, and to be transported. A simple scale-up would cause its size and weight to increase exponentially, resulting in a machine that is too bulky to move or operate. Questions of whether the supply chain could provide matched components or whether the roads could support its transportation would also arise. The team began to look for solutions beyond crane engineering and found one in bridge construction. The towers of cable-stayed bridges are mostly H-shaped or A-shaped, with 2 load-bearing arms sharing the load. Given the crane's similar load-bearing mode, would dual-arm load-bearing be feasible? As a result, the team came up with the double-boom 8-chord rod design plan. However, the plan was only on paper, and there was no example to follow. So, how could this plan be turned into reality? Naturally, the 216-meter-long boom couldn't be completed in one go. Even if it could, it would be impossible to transport it. The only feasible solution was to break it into sections for manufacture. However, the team wouldn't know just how large a section should be until they were in the manufacturing workshop themselves. The boom was divided into 72 sections, with the largest being 12 meters long, 3.5 meters wide, and 3 meters tall, roughly the size of a 42 square meter room.
我们看好之后，他们都会喊我们叫空姐，觉得特别威风。其实这个工作并不是想象中那么简单，危险系数特别大，因为我们要保证物的安全、人的安全，每一个细节，翻转的力度、主钩起的多少，还有小车行走的多少，这个都需要你记在心里了。
In the 35,000 square meter welding workshop, sections of the boom are laid out one after another. To complete the precision welding of these 72 sections, welders must rely not only on eye-head-hand coordination, but also their ears in discerning subtle variations in sound.
听到这个焊接的这个声音啊，感觉到非常悦耳。所以我给我的徒弟了教，你如果能从它焊接的这个声音，然后能听到它的电流电压调节是不是正确，这就是已经达到了一个焊工的基本水平。
The welding sparks are a familiar sight in the welder's daily routine. Driven by hope and determination, they are turning a dream into reality in the building of mega machinery. The double boom approach solved the issue of lifting, and the segmented manufacturing addressed the issue of transportation. But that wasn't enough. The mobility issue still needed to be tackled. In China, an increasing number of offshore heavy operations concerning national economy and people's livelihood, such as bridge and tunnel construction, dismantling of decommissioned platforms, lifting of super-large modules, deep-sea energy development, and underwater salvage and rescue, are giving birth to a variety of large-scale offshore lifting equipment. Meanwhile, these operations demand ever higher standards in lift capacity and operational precision. On Shanghai's Jiangxin Island, the overload stress test for Zhenhua 30 is about to begin. The test includes two parts, the first of which is the full slewing overload test. Full slewing hoisting is where the crane rotates 360 degrees to perform its hoisting work. When Zhenhua 30 is in full rotation, its rated maximum lifting capacity is 7,000 tons. The full slewing overload test involves hoisting a load 1.1 times the maximum capacity, which equates to 7,700 tons. It would be equivalent to lifting 128 high-speed rail carriages, each weighing 60 tons, and rotating them round a half circle.
我们也知道额定跟超载这两个词它就不一样了。额定它是有一定安全的保障系数在里面的，但是我们超载这一块来说，所有的电气系统是吧，液压系统能不能达到这个更高的要求？
Since Zhenhua 30 already has a rated maximum lifting capacity, so why is the overload test needed? Unlike working on land, offshore operations are susceptible to wind, waves and ocean currents. As the world's most powerful floating crane, Zhenhua 30 must complete challenging lifting tasks under extreme sea conditions. Whether all performance indicators can reach their optimal levels, and whether the components can remain safe and stable under overload conditions, can only be known through these overload tests. So, Zhenhua 30 must pass this grueling limit test. Failure is not an option. The test barge serving as the load to be hoisted has been brought up to a weight of 7,700 tons through additional ballast. There are 44 steel cables on each side of the barge, each as thick as a human calf. They have been securely attached to the main hook of the crane. Zhenhua watches the position of the boom intently while keeping a close eye on the changing data on the screen. the main hook slowly lifts the barge from the water's surface. However, this is only the first step. The next step will test the crane's ability to hoist the load while rotating, and the key to the rotation is its chassis. The chassis weighs 2,200 tons and has a diameter of 42 meters, which is approximately the length of 9 family cars lined up end to end. If we think of the hooks as Zhenhua 30's hands, the boom as its arm, and the hull as its legs, then the chassis would be its waist. By twisting its waist, it can lift the 7,700-ton barge from one side of the hull to the other. While supporting the crane's own weight of 20,000 tons, the chassis also has to bear the weight of the 7,700-ton barge. How can the crane turn under such a heavy load? Chief designer Yan Bing was faced with an unprecedented design task. He knew that the key for the chassis to bear such an enormous load and rotate were the load-bearing rollers on its track. But the question was, how many rollers were needed, and how could they be arranged to ensure even distribution of stress while minimizing wear and tear? In the end, the design involved arranging 690 rollers on 2 concentric tracks, with each pair of rollers forming a set. This proved to be effective not only in solving the difference in rotation speed between rollers on different tracks, but also allowed for mutual support between the rollers. On Changqing Island, the rotation of Zhenhua 30's chassis begins. The 345 sets of twinned rollers slowly but forcefully move over the tracks. Under Zhenhua's scrupulous supervision, the barge, which has already been lifted from the water, is rotated from Zhenhua 30's bow toward its starboard side. The journey took 20 minutes, after which the barge hovered for a few minutes before being gently lowered back onto the water. With that, Zhenhua 30 had passed its full slewing overload test. China's first high-speed railway, the Beijing-Tianjin Intercity High-Speed Railway, spans 166 kilometers and took over 3 years to build. Since then, China has built a high-speed railway network of over 40,000 kilometers, the biggest in the world. If all of China's high-speed railways today had been constructed at the same pace of the first, it would have taken 720 years to complete. However, in reality, China has accomplished this feat in just 18 years. So, how was this rapid acceleration achieved? In Jiangzhou, Fujian province, under the scorching midday sun, at the girder yard of No. 9 section of the Fuzhou-Xiamen-Jiangzhou high-speed railway, a massive gantry crane is lifting the 114th precast concrete box girder. It measures 40.64 meters in length, 12.6 meters in width, and weighs 1,000 tons. At the girder yard, rows of box girders are neatly arranged, awaiting delivery to the construction site 8 kilometers away. High-speed railways differ from highways. Due to the high speed the trains will travel at, the chosen routes must be as straight and flat as possible. This means constructing high-speed railways often necessitates tunneling through mountains and building bridges over dips in the terrain. Jiangzhou is located in the low-altitude hilly region of southeastern China. to cross the valleys and rivers, the Fuzhou-Xiamen-Jiangzhou high-speed railway requires the construction of tall, deep-set foundational piers. This type of operating environment is often referred to as a high pier area. Moreover, given the preciousness of land in the southeast coastal area, bridge piers have been increasingly spaced apart to minimize their encroachment on agricultural land. The traditional cast-in-place concrete method is no longer suitable, necessitating the adoption of a construction model called bridge through holes with prefabricated box girder. Consequently, the length of the box girders has increased from the initial 16 meters and 24 meters to the current 32 meters and 40 meters.
我们国家高铁走的是一个技术引进，然后再吸收借鉴，然后再到一个自主创新突破的这么一个路线，这我觉得是我们国家发展的一个小小的缩影。
The 114th box girder has now been hoisted onto a special 1,000-ton girder transporter. Because there are many tunnels along the route, the 1,000-ton girder transporter uses a trough-type design to comply with tunnel height restrictions. The box girder is placed on the trough-shaped transporter, reducing the overall height of the vehicle and allowing it to pass through tunnels. Additionally, the 4 vertical, 8 horizontal framework, made up of 224 wheels in 28 sets, efficiently distributes the weight of the 1,000-ton box girder. At the construction site, the highly challenging span-by-span bridge erection is about to commence. The space between bridge piers is referred to as the span, and the process in which the bridge girder erection machine moves from one pier to the next is called spanning. The ultimate purpose is to place the box girder onto the 2 piers. The 1,000-ton bridge girder erection machine is composed of a main beam, lifting trolleys, and 5 different outriggers, each with autonomous movement and extension capacity. This allows the machine to move forward on the finished bridge deck while erecting the bridge. To build a bridge section between 2 piers, the machine must first keep its footing on the piers. So, the first step of spanning involves moving the main beam forward, allowing the outriggers to move quickly onto the pier head. However, the problem is, as the main beam progressively advances, weight is shifted to the front of the machine. With this massive 680-ton machine hanging in mid-air, continuing to move forward, if it cannot maintain its balance, it will topple.
一般的人眼中觉得吊起了个1000吨的梁，可能觉得是最危险的工况，其实过孔才是这个设备风险最大的工况。如果它的姿态倾斜角度过大，会对整机造成一个倾覆。
So, how can the machine cross the span between the piers while maintaining its balance and avoid toppling? At this point, the 2 lifting trolleys act as counterweights. They slide from the front of the main beam to the back to maintain the overall stability of the machine. Among the 5 outriggers, the one at the very front is the front auxiliary outrigger. It's designed to be the thinnest. When the main beam moves forward, it hangs from the front end of the boom with the minimal weight, ensuring the balance of the entire machine even when the front section is suspended.
前幅特别关键是它是卡控整个槽机的过孔的位置，因为前边比较远，没有放到位的话，可能会导致咱们下一孔向梁架设的过程中，向梁落不下去这种情况。
Once the front auxiliary outrigger has moved to the next pier, it extends automatically from 8.1 meters to 12.23 meters until it is firmly established on the pier. There it becomes the first new pivot point for the machine during the spanning process. Liu Xiaoning and the crew's immediate task is to position the front outrigger onto the pier. The thin front auxiliary outrigger alone is insufficient to bear the 1,680-ton weight of the machine and the box girder. the front outrigger must be in place to support the load. With the temporary support of the front auxiliary outrigger, the robust front outrigger slowly slides forward until it is firmly on the pier. The main beam has successfully advanced. Lin Junjie and his girder transport team have delivered the 114th concrete box girder to the site. The rear outrigger at the tail of the machine begins to fold backward to make room for the transporter, allowing the girder to enter the machine's lift span. In the main control room of the bridge erecting machine, Bang Zhefan oversees the two lifting trolleys working together to grab the box girder at both ends and place it between the two piers. The machine works with the transporter to accurately lower the box girder. They complete the spanning task with elegant efficiency. At Lianyungang Petrochemical Industrial Base in Jiangsu, the vacuum distillation tower has been safely hoisted to a height of 92 meters. It looks like a massive alien spaceship suspended in mid-air. The 4,000-ton level crawler crane will carry the distillation tower to right above the installation point by chassis rotation. Conventional heavy-duty cranes usually comprise two sections, front and back. The back primarily serves as a counterweight, while the front carries out almost all tasks, including lifting, rotation, and movement. The 4,000-ton level crawler crane also consists of a front and a back section. However, as the total weight of the crane, counterweight, and load exceeds 10,000 tons, if the crane relied solely on the front section for power, its mobility and lifting capacity would be severely affected by overloading the front section. So, how can this be dealt with?
4千吨它是靠后车推着前车走，后车相当于小毛驴，前车相当于磨盘，然后毛驴就是拉着磨盘走嘛。
The power of the crane is divided between the front and the back sections. The 6 winches responsible for lifting are installed on the front section, while the power system that drives the crane's rotation is installed on the back section. During rotation, the front section focuses on lifting, while the back section drives the rotation, just like a donkey turning a millstone. The setup allows the crane to make full use of its lifting capacity without compromising its movement. With the back section powering the rotation, the engine begins running at high speed, producing a deafening noise. However, in the driver's cab, it's extremely quiet. Mr. Li, a seasoned crane operator with 14 years of experience, is highly focused. There is no room for distractions. This is the enigmatic semi-anechoic chamber, where sound-absorbing wedges are embedded in the walls and the ceiling. When running at high speeds, the crane's engine generates considerable noise, which is caused by intense vibration. The vibrations can not only shorten the vehicle's lifespan, but also damage people's nerves and mental well-being. The cab of the 4,000-ton level crawler crane is placed in the center of the chamber. Zhuang Chao conducts noise tests on the engine. When the noise spreads to the sound-absorbing wedges around it, 99% of the energy is absorbed, preventing any reflected sound from interfering with the testing process. The engine is started in silence, and its deafening roar echoes through the chamber. However, inside the operator's cab, things are very different. Thanks to the meticulous efforts in noise reduction and vibration damping during the development process, the noise inside the cab is minimal compared to the outside.
最终的目的就是为了降低作业过程当中产品的噪声，避免它对作业过程以及人的健康产生一些影响，对人对环境的一个关怀。
The sound source and transmission paths, when the engine is running, are accurately identified. Designers will use this information to optimize the design scheme to ensure that crane operators can concentrate on completing heavy lifting tasks in a more comfortable and safer working environment. On site, the powerful chassis slowly rotates. Its ultra-high-strength steel rollers move slowly and steadily along their tracks, hoisting the vacuum distillation tower directly above the installation point. With the winches operating at full power and their 60 steel cables at maximum tension, the tower is slotted into place. The operation has been a success. While Zhenhua 30 has passed its first overload test at Changshin Island, Captain Tang Hongliu can't relax yet. He closely monitors the various dynamic datasets because the upcoming fixed hoist overload test is even more challenging. A fixed hoist refers to the crane's rated maximum lifting capacity when it is stationary. For Zhenhua 30, this is 12,000 tons. During an overload test, however, the crane must lift a load 1.1 times that amount, or 13,200 tons, equivalent to 220 high-speed rail carriages.
做这个实验，我们的心里还是有点紧张。我们做了很多的预案，调账计划进行反复的讨论，认为这个计划是完美的。一点一倍做了以后，对我们后面的工作，我们就更有信心了。
Tang Hongliu understands that the upcoming test will subject the bow of the Zhenhua 30 to unprecedented pressure. He must carefully adjust the water level in each ballast tank to ensure that the lateral and longitudinal inclinations of the hull are kept within 1.5 degrees. Any error could cause the hull to lose stability, with potentially catastrophic consequences, including capsize. "88 thick steel cables have been connected to 88 lifting points, and the weight of the test barge is again increased from 7,700 tons to 13,200 tons. If the full slewing test is a test on the crane's waist, the fixed hoist test is a test on its arm.
这个12000的浮吊上面配备的2个6000吨的四爪钩。这个四爪钩呢，它的本身这个体积达到这个3.5乘3.5米，这个高度呢达到2.2米，相当于我们一个12平方的卧室的一个体积。吊钩的重量呢达到220吨左右，相当于我们的家用小汽车的150辆小汽车这样一个重量。
In addition to the giant 4-claw hooks, the crane's boom is equally astonishing in size at 125 meters long and weighing 2,000 tons. It consists of 2 segments, forming a stable triangular structure, concentrating the force onto a single lifting point. As the crane's operational alert sounds, the giant 4-claw hooks firmly grab the 13,200-ton barge and slowly lift it from the water. Chief Engineer Xu Lin is closely monitoring the operation of the engine room. In China, a chief engineer is commonly called the old rail. The term was supposedly invented at the time of the Industrial Revolution. Since railways and steam locomotives had preceded steamships in China, by the 1930s, some who had previously worked on railway locomotives began working as engineers on steamships. Consequently, they earned the nickname rails, and the chief engineer was respectfully referred to as the old rail.
这个实验其实我们机器这一块，我感觉还是我有信心的，肯定没问题的。因为这条船我付出了很多的，我感觉就是船好像有个生命的一样。你把你主管的设备就当它有生命的，你管理才会好。你要是关注不到了，总归它要发脾气的，给你找点麻烦。
In the engine room, the 10 engines, each with an installed capacity of 7,000 kilowatts, run smoothly. Xu Lin's task is to maintain the proper functioning of the ship's mechanical equipment and get it through the overload test. The 13,200-ton test barge is lifted 2 meters above the water and is suspended there for a few seconds. This signifies the successful completion of the fixed hoist overload test. In Jiangzhou, Fujian Province, at the construction site of the No. 9 section of the Fuzhou-Xiamen-Jiangzhou high-speed railway, Lianyungang is pacing around the bridge erector. He alternates between listening to the sounds of the machine in operation and climbing up the scaffolding for an overall view of its operating posture. As the critical piece of equipment developed for the project, he is fully aware that this is the most vital moment of its operation. A tunnel appears ahead.
我们既要跨越40米跨，我们又要通过隧道，架下机的外形尺寸受到很多的限制。
Jiangzhou's hilly terrain makes passing through tunnels a frequent occurrence. The tunnel ahead is 9.5 meters tall and 13 meters wide, while the machine is 10.3 meters tall and 20.5 meters wide. Obviously, the mega machine can't go through the tunnel.
研发一个最大困难点就是咱们那个1000吨级加油机要在隧道口架梁和通过隧道，因为40米的箱梁它的高度更高，隧道通过性和架梁这是最大的一个难点。
To pass through the tunnel, the machine must slim down. The central outrigger is the key. Among the machine's 5 outriggers, the central one is the thickest and most robust. Its shape means it's also referred to as the O-shaped outrigger. As the box girder needs to pass through the O-shaped outrigger during the girder erection, the width of the O-shaped outrigger must reach 20.5 meters, too wide for the tunnels.
O 型腿呢，有点像我人体啊，当我叉着腰，雄赳赳气昂昂的过不去，怎么办？我只有把自己的往回一收，通过肩关节一收，再把我们的肘关节一收，这样的话就变成体积更小了，才能通过狭窄的隧道。
The key to the slimming down of the central outrigger is folding. First, the lower crossbeam of the O-shaped outrigger is removed, allowing its joints to move freely. Then, the curved vertical beams are folded forward 90 degrees and upward 75 degrees, like a giant bird folding its wings. This reduces the width of the machine from 20.5 meters to 11.14 meters and its height to 8.81 meters. It can finally pass through the 13-meter wide and 9.5-meter tall tunnel.
体现的就是我们一个仿生学的原理，通过人体 这么一些关节的配合更好的收缩起来，通过这个下载空间。
However, a new issue now arises. With the lower crossbeam removed, the machine has lost its ability to move. How then can it pass through the tunnel? The solution is the girder transporter, which carries the bridge erector by lifting the girder carrying support frame. With the girder transporter team and the bridge erector team working in tandem, the two pieces of equipment enter the tunnel together. However, huge risks persist. The gap between the widest part of the machine and the tunnel wall is just 12 centimeters. Any slight deviation could result in a collision.
这必须需要4个人，每个脚位都要站一个。是运输箱梁过程中对隧道壁容易误碰撞，造成箱梁损坏。
Collisions not only damage the equipment but can also cause casualties. Zhou Jie sits comfortably in his operator's cab, unburdened of the need to do anything, because once in the tunnel, the machine switches to a self-driving mode.
自动驾驶系统它的一个原理，运粮车沿着隧道中心线，然后这样行驶，然后保证箱梁跟隧道壁两边那个间隙基本上保持一致，这样的话保证那个整个运输通过隧道的一个安全性。
A laser radar system accurately detects the distance between the bridge erector and the tunnel wall. When the gap is too small, the system will issue an alert and correct the path accordingly. The 4,000-ton level crawler crane is the product of 1,800 days' work by over 100 developers making more than 16,000 design drawings. It incorporates over 80 national patented technologies and has run successfully and safely for 8,468 hours. Out at sea, the Zhenhua 30 has passed both overload tests. Captain Tang has had his mind put at rest. The giant ship can set sail again for its next offshore operation. At the current work site of No. 9 section of Fuzhou-Xiamen-Jiangzhou high-speed railway, the slimmed-down bridge erect machine and the girder transporter slowly emerge from the tunnel. There are many more high piers waiting for them ahead. Through effective cooperation, the two machines can erect 2 bridge sections each day and build 1 kilometer of high-speed railway in just 12 days. This is what has made possible the acceleration of China's high-speed rail construction. These mega machines, the brain children of Chinese engineers, are powerful, dutiful, and tireless. These traits will never change, regardless of how the equipment evolves, as they are also the traits of their devoted Chinese engineers and operators. Away from their loved ones, they stand fast at their posts in distant lands, despite homesickness. With determination, they produce sophisticated equipment, making the extraordinary out of the ordinary. They are the real stories behind China's mega machines.
92年做到现在，就已经29年了。
我今年31岁了，从事这个行业有11年了。
陪儿子、陪爱人的时间非常少。
家长会啊，估计肯定不会超过5次。
孩子21了，上大学了。他的生日，我每年都记得，都给他买东西，但是只参加过1次，他很不理解嘛。然后他和我也不亲，哎，怎么说了？不能说了，不说了，不说了。
父母的年龄越来越大，陪伴在他们身边的时间少之又少。
当时我岳母摔倒了，那个腹股头摔断了，我妈正好也在住院，哎，我老婆在上班，心情真是又回不去，因为我们在海上面在施工。
开心的就是为国家高铁事业做贡献了吧。
老在外边飘着，只有自己默默承受呗。这有些东西也没法表达出来，但是大方向不能变，以国家建设为重吧，舍小家顾大家吧。
我35岁的时候，我得了急性早幼类白血病，治好了这个病了以后，我觉得时间更加宝贵，所以我把每一天，我都把它看的是最后一天，我是这么来工作的。